and start working through it. So we have equations 1, 2, and 3, and usually, like we did yesterday on our regular paper, we labeled. They're already labeled for us. I'm just going to go ahead and label it like I would on a piece of paper. So there's equation 1, there's equation 2, there's equation 3. Now, with our first thing we need to do is we need to choose one of our variables to eliminate. And this one is suggesting that we eliminate x, which makes decent sense because both the x in the first equation and the third equation just have a negative in front of them. So these are already set up to eliminate. And you could just leave both equations exactly as they are and subtract the equations to get rid of x here. That's fine. The book, though, is going to suggest that you multiply one of the equations by 4. Oh, okay. So it's not suggesting to match up 1 and 3 first. It's saying match up 1 and 2 first. All right, that's fine. So multiply equation 1 by 4, and then it'll have the opposite value in front of x. That's fine too. Let's just start with that. So if you multiply everything in equation 1 by 4, that'll give us negative 4x here. 5 times 4 would be 20y. Negative 4 times 4 would be minus 16z. And then negative 2 times 4 would give us negative 8. So we have equation 1. Equation 1 right here. And then we have equation 1. Equation 1. That's equation. Yeah, that is equation 1. Okay, I'm very tired this morning. Okay, this is equation 1 times 4. And then this is equation 2. All right, there we go. We have equation 1 times 4 and then equation 2. And if you look at what happens here, everything cancels. The negative 4x added to the 4x cancels out. That was the one we were trying to eliminate. But also the negative 20y and the 20y add together and cancel out. The negative 16z and the 16z cancel out. And the negative 8 and the positive 8 also cancel out, leaving us with 0 on the left and 0 on the right. The equation 0 equals 0 is always true, which indicates that the first two equations represent the same plane because they end up being exactly the same. They cancel each other out. So basically, like equations 1 and 2, if you think back to yesterday, an equation with 3 variables doesn't represent a line, but it represents a plane, a flat surface. And with the multiplication, it ends up being that both planes are identical. Sort of like when you're dealing with 2 variables, both lines ended up being identical, then everything canceled and you got the same number on both sides. So we know that the first 2 end up being the exact same plane. What we don't know is what's going on with the third one. So we know that those 2 are identical. 1 and 2 are the exact same plane. So let's eliminate x in either 2 and 3 or in 1 and 3. Because we want to see what's going on with the third plane here as well. Because if all 3 planes are identical, then all 3 stack perfectly onto themselves. Now, there is a possibility that you have 2 planes that are exactly the same, and then the third one cuts through it, which would then mean there's an intersection of the 2 planes that are the same and the 1 plane that goes through it, which means the answer would be a line. And so we're just going to try to figure out if that's the case. So if you multiply the first equation by negative 1, this is where I was thinking about where we would go initially. And this is honestly the way that I would probably start the problem, is to match up 1 and 3, just because negative x and negative x match up really nicely. And if you do that, you can see that it's suggesting that we multiply the first equation by negative 1, which is fine. We don't have to do that, but the book is suggesting it. So let's go ahead and do that. So we multiply the first equation by negative 1. Negative x times negative 1 is x. 5y times negative 1 is negative 5y. Negative 4z times negative 1 is positive 4z. And negative 2 times negative 1 is 2. And so we're going to have ourselves equation 1 times negative 1 over equation 3. Those are the 2 that we're matching up. And if we add all the way through, the positive x and the negative x are going to cancel. However, a negative 5y plus a negative y doesn't cancel out. That gives us negative 6y. And a 4z plus a negative z would be 4z minus z. Doesn't cancel out either, gives us 3z. So we get negative 6y plus 3z, which means not all three planes are identical, because if they were, this would end up being 0 equals 0 again, which it isn't. If you have two variables in an equation, what does that make on a graph? Makes a line. So the two planes intersect in a line because the resultant equation is in two variables. If there's three variables, it's a plane. Two variables represents a line. So regardless, if it was, the answer is the same either way, but it's not infinitely many because all three planes are the same. It's infinitely many because two planes are the same and the other one goes through it at a line. So there are an infinite number of solutions. Now, just to be clear, unless the problem specifically asks you how they intersect, if they're all three the same plane or if they intersect in a line, unless it specifically asks you that, I don't need you to figure that out. If you get to this point right here, and it just wants you to answer it, you can stop here and say infinitely many solutions. I'm fine with that. If it tells you to figure out how they are related to each other, are all three of them the same plane, or are two of them the same, and then one of them isn't, and so they intersect at a line, then I would need you to keep going with that. But unless it specifically says, you don't need to go any further than this. I just want to make that clear before we move on. Now, had we started with setting up 1 and 3 together, we wouldn't know that it was infinitely many solutions, because we would have started with those two equations and we would have gotten this, which would suggest that there would be a solution that is a specific solution. And then we'd have to match up, a couple of the other planes, and we would eventually find out that it's infinitely many solutions. But sometimes infinitely many solutions isn't going to reveal itself immediately, depending on which two equations you match up initially. So sometimes it takes a little bit more work to figure that out. Sometimes the answer reveals itself pretty quickly. All right, time for the paper. So get some paper. We're going to work through both of these. And we'll do the first one together. And then I'm going to have you work on the second one, either by yourselves or just with somebody right near you, just to see how this goes. So let's try out our first check step down here. You're going to need some paper for this because we do not have enough room in the margin to work through both of these problems, or probably even one of them. So our first check step, go ahead and write down each equation. 3x minus 18y plus 6z equals 7. And then 7x minus 2y plus z equals 1. Negative x plus 6y minus 2z equals negative 2. Okay. So this is the equation that we're going to be solving. The system of equations with three variables. So we've got equation 1, we have equation 2, we have equation 3. All right. So taking a look here. Which of the three variables seems like it's the best candidate for elimination? Y would be fine, X would be fine, Z would be fine. I don't really think, I would probably go with either X or Z, just because there's no coefficient in front of X here, there's no coefficient in front of Z here. So starting with eliminating X or Z is fine with me, but if you also think about this, there's not a whole lot of math that needs to be done to get the same number in front of the Y's either, right? 2 times 3 is 6. 6 times 3 is 18. So there's not a lot of work that would need to be done to eliminate any one of those three variables. So first one I hear, Z. Okay, let's get rid of Z then. So which two equations do you want to match up first? 2 and 3. All right, what do we need to do to equation 2 to get the same or opposite value in front of Z? Multiply it by 2. All right, So instead of rewriting equations 2 and 3 normally, we know that we have to multiply this one by 2 to get the opposite value in front of z. Yeah. Oh, because we need to get the same number in front of the variable that we're eliminating. Okay. Yeah. So the way that we're going to get a 2 in front of z here, because that's a -2. If we match both of those up and we're eliminating z, this one has a -2. This one doesn't have a number in front of it. And so if we multiply this by 2, that'll be a +2. That'll be a -2. And if you add them, they cancel. Yeah. So we'll multiply equation 2 by 2. And so this is going to be, I'm going to write 2 times 2. That's equation 2 times 2. And then if we multiply everything in equation 2 by 2, that'll be 2 times 7x, which is 14x. We will have 2 times -2y, which will be -4y. And we'll have 2 times z, which will be +2z, equals 2 times 1, which is 2. We don't need to mess around with equation 3 at all. It's already got a -2 in front of z, and that's the one we're canceling. So here's equation 3, regular equation 3. -x plus 6y minus 2z equals -2. And we're just going to go ahead and add all the way through. And we're adding here because the numbers in front of z are opposites. And the only way to cancel out opposites is to add them together. So we'll add both equations. 14 plus -1 is 13. So that'll be 13x. -4 plus 6 is 2. So that'll be +2y equals 0. The 2z and the -2z are going to cancel. This is equation 4. All right. Now, the next thing we need to do is match up either equations 1 and 3 or equations 1 and 2. We've already matched up 2 and 3. So 1 and 2. Okay. We should probably keep equation 1 exactly the same. And then equation 2 should be multiplied by what? By 6, yeah, or by -6, either way. If you want to get the same number in front of them, multiply by 6 and we'll subtract the equations. If you want to get opposite values, so you can just add the equations together, then multiply by -6. I'm just going to multiply by 6. So equation 1 is going to be exactly the same as it was. And equation 2 is going to be multiplied by 6. So we're going to have equation 1 and then equation 2 times 6. Equation 1 is going to be 3x minus 18y plus 6z equals 7. And then multiply by 6. 6 times 7, 42x. 6 times -2, -12y. And then plus 6z equals 6. We're going to add those together. 42 plus 3 is 45x. What's that? Oh, you're right. I'm sorry. We'll subtract. 3 minus 42. There we go. My mistake. Those are not opposite values in front of z. 3 minus 42 would be -39x. -18 minus -12 would be -18 plus 12, which is going to be -6y. And then 6 minus 6 is going to cancel. And then 7 minus 6 is 1. All right, that's equation 5. So now that we have equations 4 and 5, we're going to go ahead and match those together. But let's just take a look here for a second. If we wanted to eliminate either x or y, looking at equations 4 and 5, because now we're down to only 2 variables, the same 2 variables with those, which is why we had to set up 2 different versions to eliminate z, so we can get 2 different versions of equations that have only x and y. Which variable looks like we can eliminate pretty quickly here? The y variable, yeah. Because this one has a 2, this one has a -6. This one will need to be multiplied by what? 3. Yeah, if we multiply the equation 4 times 3, that'll give us a -6 in front of y up here, or a +6, which would then be the opposite of -6, and we can add them together. So I'm going to say, here's equation 4 times 3, and then equation 5. We're not going to change equation 5, but we're going to multiply equation 4 by 3. What is 13 times 3? 39. Yeah. 13 times 3 is 39. Plus 6y equals 0 times anything is 0. And that'll be negative 39x minus 6y equals 1. What ends up happening here? We're going to add these together this time. We're not going to subtract them. And I'm thinking about this a little bit more on this one. Everything cancels. Okay.
What happens to you?
So this would be 0, right? Over here, what's 0 plus 1? 1. But 0 does not equal 1. What does that suggest? There's no solution. This is like with a linear equation. In fact, these are linear right here. So those are linear, which means, there's no intersection between those. Those lines are parallel, which means there's no solution. So for this entire system, there is no solution, which is kind of nice. Once we get to that point right there, we don't need to keep going. Once you see that there's no solution, you can just be like, all right, I'm done. No solution. Variables are gone. Equation doesn't make sense. There's no solution. All right. I'm going to give you 5 minutes. I want you to try the next one. So take 5 minutes. Work with someone if you want to work with someone. Try it on your own if you want to try it on your own. But you got 5 minutes. And at 8:25, we'll check back in. So we've got our answer there. Let's go ahead and look at the last problem. This is a word problem. There are a few word problems on your assignment, so this will be a good one to take a look at. So here we go. In 2016, Dali Museum in St. Petersburg, Florida, offered individual, dual, and family memberships, which cost $60, $80, and $100 respectively. Suppose in 1 month, the museum sells a total of 81 new memberships for a total of $6,420. The number of dual memberships purchased is twice that of the individual memberships. Write and solve a system of equations to determine the number of new individual memberships X, dual memberships Y, and family memberships Z. So it's defining our variables for us, which is kind of nice. We know that there were a total of 81 new memberships. So it's telling us right here, this is going to be one of our equations. And if you write an equation to represent the number of total new memberships, what would that look like? Yeah, the number of individual memberships, X, plus the number of dual memberships, Y, plus the number of family memberships, Z, equals the total number of new memberships, 81. All right. The number of dual memberships, which is Y, purchased is twice that of individual memberships, which is X. What would that look like? There's only 2 variables in this equation. Dual memberships are twice that of individual. So there's only 2 things being compared here. We're not talking about total number of memberships here. What does is mean in math? Equals. So dual memberships Y is equals twice that of individual memberships, which is X. Equals 2X. Is means equals, yeah. All right, the fee for individual, dual, and family memberships, which cost $60 and $80, $60, $80, and $100 respectively, for a total of $64.20. This is going to be more similar to the first equation. Not the same, but it will use all 3 variables because we're talking about individual, dual, and family memberships. Thoughts on this one? Yeah. Total amount of money. So $60 times the number of individuals plus $80 times the number of duals plus 100 times the number of families equals the total amount of money, which is $6,420. All right. We have ourselves three equations. So here's equation 1. Here's equation 2. Here's equation 3. You won't always have all three variables in all three equations, which actually makes it a little bit easier. So because we know that y is the same as twice x, it's suggesting that we substitute in 2x for y into equation 1 and equation 3, which would eliminate y without having to match up different, versions of each of those equations. Because if you plug in 2x for y, because y is equal to 2x, we stated that right here. Instead of writing x plus y plus z, you can write x plus 2x plus z, because y is the same thing as 2x. And if you add x and 2x, you get 3x. That's 3x plus z equals 81. We've eliminated y from the first equation without really having to do much, because we just substituted instead of match things up. You could, I wouldn't necessarily recommend it though, because if you were to write this one like the other equations, you'd have to write something along the lines of like negative 2x plus y plus 0z equals 0 in order to get them to match up on top of each other. Does that make sense? Yeah. You could. I feel like it would definitely take a little bit longer that way, but if you wanted to keep the exact same process, this is more like using the substitution method from systems of two equations, where you're just plugging in something for something else. Just a straight swap, which in this case, I feel like is a little bit quicker. And so we're basically going to mix and match substitution with elimination in this process. So for the next one, we're going to take the third equation and we're going to do the same thing. We're going to plug in 2x for y. So instead of 60x plus 80y, we're going to have 60x plus 80 times 2x, because y and 2x are the same thing. And then if you multiply 80 by 2, what do you get? 160, but that's 160x plus 60x. What's 160 plus 60? 220. So that's 220x plus 100z equals 6420. Now we have equation 4 and equation 5. So we've created equation 4 and equation 5 actually a lot quicker than we normally do, because we had a variable already solved for here, which meant we could just substitute it into the other two equations to get rid of that variable. And so now we're going to line up equation 4 and 5, but we're going to make an adjustment to equation 4. It says to multiply equation 4. I'm going to go ahead and multiply equation 4. I'm going to change that. Multiply equation 4 by negative 100. So I got rid of the word new and I changed the 1 to a 4, because we'll just call that equation 4. I want to keep that part consistent. And so this is going to be equation 4 times negative 100. So here's 4 times negative 100. And then we've got equation 5. And they're multiplying it by negative 100 because, well, they want to eliminate z. So if you multiply everything here by negative 100, that'll be negative 300x minus 100z equals negative 8,100. And if you add all the way through, the 100z and the negative 100z cancel. Negative 300 plus 220 is negative 80. And negative 8,100 plus 6,420 is negative 1,680. If you divide both sides by negative 80, x is 21. Which means there were 21 individual memberships sold. And then if we go back to solve for z, we can go ahead and substitute in z. Looks like they're using it in equation 4. So here's equation 4. What's that? Oh, yeah. And, they're plugging it back into equation 4, because if you want to find the variable z, you got to plug it back in for the one of the two equations that we had with just x and z. And since equation 4 had much smaller numbers, that's why they're using this one. So we know that x is 21, so we're going to get 3 times 21 plus z. 21 times 3 is 63. And if you subtract 63 from 81, you get 18. That's where that came from. And then Z is 18. We got that. Now, the nice thing is that solving for Y, we don't have to plug it back into one of the original equations that had all three variables. If you want to solve for Y, you can just plug it back into equation 2. Y is equal to twice the amount of X. So here's equation 2. X is 21. 21 times 2 is 42. So 21 individual memberships, 42 dual memberships, and 18 family memberships would be the solution to this one. So here we go. Individual memberships sold 21. Dual memberships sold 42. Family memberships 18. There we go. All right. That's all I got for you. We got 15 minutes. Your problems that you're working on are 1 through 21 odds. I put that up there yesterday. So it's going to take a little bit of time. So this assignment will probably take maybe a little bit longer than normal. There's about 10 total questions that you need to do, and you know that they take some time to work through. So get working on these. We do not have TAT today.